Okay, these are notes 3.6. 3.6 is kind of a long section, so we're split it up over 2 days. I think there's 3 pages of notes to go over here. Couple things to talk about. Okay, so first thing is the intermediate value theorem. Basically, if I have P of A, so if I plug A in here and I get P of A is up here, and I plug B in here and I get P of B, the output's down here, right? So I have an input up here and an output up here and an output down here. If those are opposite signs, so if one's positive and one's negative, I know then that there has to be a zero, a real zero. Okay, and a zero, remember, is a solution, right? A real zero between A and B. Okay, so if I plug this A in and I get this B, this output, if I plug B in here and I get this output, I know that somewhere between these 2 points there's going to have to be a real zero in there somewhere. Okay, so to show that, here's our P of X function. If I find P of 2, plug a 2 in here and here and here, plug a 2 in for all those, I get -1. And if I find P of 3, plug a 3 in here, here, and here, plug it in, I get 7. Okay, so basically if we look at this graphically, I know that if I plug in a 2, I get a y of -1. If I plug in a 3, I get a y of 7. So I know that between these two, between 2 and 3, there's got to be a 0 in there somewhere. Okay, so there has to be a 0, a solution between 2 and 3. So 2 point something is going to be a solution in there. Okay, so to show, pause it and do this one. Okay, so to find P of -1, that's equal to -6, and P of -2 is 1. So if you think about this graphically, if I plug in a -1, I get -6. If I plug in a -2, I get 1. So I know somewhere between here there's got to be a 0. There's got to be a solution. Okay. There has to be a 0 between -1 and -2. Okay, so that's what the intermediate value theorem says. Okay, now on to division. We're going to divide polynomials 2 ways. We're going to use long division like this, and we're going to use synthetic division as well. Okay, if you think about long division, it's really kind of the same idea as this. Okay, remember back in middle school when you did a long division, we thought what times 3 is 9. Okay, and used 3. And then you took 3 times 3 is 9, and then you subtract. And you brought down the next term. And you kept doing the same process over again. What times 3 is 6? 2. 2 times 3 is 6, and you subtract them. They cross out, bring down the next term. Okay, what times 3 is 5? Well, not quite 2, but 1, right? And then you got 3, and you subtract and bring down the next term. And you just keep going over and over in the same process. The same idea as this. Okay? So I left a blank here because this is like 0x squared. So we had x to the third, 0x squared, and then x in the other. Okay, so if you don't do that, you'll probably mess up adding like terms, most likely. Okay, so here's what we think. What times x is 3x squared? 3x to the third. 3x squared, right? If I take that times that, it'll give me this. So I'm going to take that 3x squared and multiply it by x minus 3 here. Gives me 3x to the third minus 9x squared. Okay, now when you subtract, if you think about when I take this minus that, right? Remember how we kind of make it an addition problem by distributing that negative through? Okay, we're going to kind of do that same thing here. Okay, we're going to draw the line and change the signs there. So then 3 minus 3, 3x to the third and 3x to the third cancel out. Okay, so if I didn't leave a space here, I'd be tempted to add these two together, right? But I can't because they're not like terms. So 0x squared plus 9x squared is 9x squared. And I can bring down the next term. Okay, now I'm just going to do that whole process over again. What times x is 9x squared? So plus 9x. I'm going to take that 9x times the x minus 3 here. gives me 9x squared minus 27x. Once again, I want to subtract, so I'm going to draw the line and change those signs, subtract it. So 9 minus 9 is 0, and that's 25x. And I can bring down that next term. Okay, so once again, same process. What times x is 25x? 25. So we take 25 and multiply by that x minus 3, gives us 25x minus 75. Once again, draw a line, change the signs. So those cancel. We have a remainder of 80, because nothing times x will give you 80, right? So we're going to say this is plus 80 over your x minus 3. Okay, so this is your answer for the division problem there. Okay, try another one. Okay, with a couple of these, I want you to pause them and try and do them for yourself, different steps, and then unpause and so forth as we go. So what times x is 3x to the third? 3x squared. Times that x minus 5 there, right? Distribute through is 3x to the third minus 15x squared. I didn't have to leave a space here because all the terms are there. Draw the line and change the signs. So those cancel. Gives me 4x squared. Bring down the next term. Okay, same process over. What times x is 4x squared? 4x. Times that x minus 5 there gives me 4x squared minus 20x. Look at this one. This one, they both cancel out, don't they? So we have 0 there, and when I bring down the next term, I have 3. Will anything times x equal 3? Nope. So that is our remainder. So plus 3 over our x minus 5. Okay. Okay, next one here. What times x is x to the fourth? X to the third. So I multiply by this, gives me x to the fourth plus 3x to the third. And subtract them. So those cancel, and I have 1x to the third. Bring down the next term. Okay, so the whole process over again. What times x is x to the third? Positive x squared. Times that x plus 4 gives me x to the third plus 4x squared. Once again, draw the line, change the signs, subtract it. So that cancels, and that gives me negative 2x squared. I can bring down the next term. So what times x is negative 2x squared? Negative 2x. So negative 2x times x plus 4 is negative 2x squared minus 8x. Again, subtract. Those cancel, and that gives me 17x. I'm sorry. Yeah. Oh, I messed up here. Back it up, back it up, back it up. 1 times 4 is not 3. That throws all this off here. Okay, now we'll try it again here. Okay, so that times 4 is 4x to the third, and when I subtract it, they cancel. So I have 0x to the third. I can bring down that next term, plus 2x squared, and I could even bring down the plus 9 plus 4. It doesn't really matter how many I bring down. Okay, so there's both are canceling there. So now I'm on to this one. So what times x gives me 2x squared? Plus 2x. So 2x times the x plus 4. Make sure I can multiply here. So 2x squared, that'd be plus 8x. And I subtract them. Gives me 1x plus 4. And what times x is x? Oh, 1. So 1 times x plus 4 is x plus 4. And you notice if I subtract them, they're exact same thing. I have no remainder. So this one works out very nicely there. Okay, next one. Once again, remember how you leave a space, x to the third, there's 0x squareds here, so leave a space there for it. And I really would like you to pause it and try it yourself if you haven't yet. So what times x is negative 3x to the third? Negative 3x squared. And multiply that through, hopefully correctly this time. And negative 3x squared there. Okay, draw the line, change the sign to subtract. So those cancel. We have 3x squared. And I can bring down the next term, or 2, or whatever you want. What times x is 3x squared? 3x. Gives me 3x squared plus 3x. And I want to subtract. So it'll be negative 4x minus 5. What times x is negative 4x? Negative 4. Gives me negative 4x minus 4. And when I subtract, I get negative 1. Nothing times x is negative 1, so that's my remainder. So negative 1 over r x plus 1. Okay, here's another way to divide. Now this one only works when you have a 1x here. Okay, so if it's just an x here. This method's actually easier, but you can't use it. Like all these had x in the beginning too, but we're going to have some where we're going to have like 2x or 3x squared or something. This only works, this is a little more limited. Okay, this is how you set it up. If you set x minus 2, x plus 2 equal to 0, you get x equals negative 2. So that kind of goes out front here. And then we're going to take the coefficients. So it's 5x to the third, negative 6x squared, minus 28x, and 8. Okay, so this is how it works. We're just going to first bring this first one down. Then we're going to take this times this and put it right here. So this times this and put it here. So it'd be negative 10. Then we add those. Together. So it'd be negative 16. Okay, then we're just going to keep doing that same thing. We're going to multiply these together, which would be 32. Put it right here, and add those together. Be 4. Going to multiply these together and add. Okay. Now this is how we get our answer here. So if I take an x to the third divided by an x, I get x squared, right? So that's our first term here. So our answer is going to be 5x squared, and then we just keep going down one. Negative 16x plus 4 and 0 remainder. See, it's easier. Just takes a little bit. You have to get used to it a little bit. Okay, so what goes out front? A negative 6. Okay, take all your coefficients. It's a 1x to the fourth, 5x to the third, negative 11x squared, minus 25x, plus 29. Okay, first one we always bring down, then we multiply and put it there and add. Okay, so that times that's negative 6, add together. That times that is 6, add together. That times that is 30, add together. That times that is negative 30, add together. Okay, so our answer is going to be 1. Okay, x to the fourth divided by x would be x to the third. So this is 1x to the third minus 1x, keep going down 1, x squared, minus 5x plus 5 minus our remainder of 1 over our divisor, x plus 6. Okay. Next problem here, let's have you guys try it. Try and do the synthetic division here by yourselves if you can. Okay, so we have 2, and then we put 1x to the fourth minus 8x to the third plus 10x, our y's, 2 and 4. Now, if there would be a term missing in there, make sure you put a 0 in there for it. Okay, if there's a term missing, we'll see that on the next one over here. Okay, so bring the first one down, multiply and add, multiply and add, multiply and add, and multiply and add. Okay, what's your answer going to be? Y to the fourth over y is y to the third, so it's going to be 1y to the third minus 6y squared minus 2y minus 2 and 0 remainder. Works nicely. It's a lot quicker than the long division, but notice, remember, this only works with a y there. Okay, this one here, that's an x plus 4, so what goes out front? A negative 4. Okay, we have 8x to the fifth, 32x to the fourth, 0x to the third, 0x squareds, and then we have x, and then we have our number. Okay, so don't forget those there or else it'll throw it off. Okay, so bring down the 8, and we multiply, it'd be negative 32, and we multiply and add, and we multiply and add, and we multiply and add, and we multiply and add. Okay, so what's our answer? We have 8, x to the fifth over an x, it would be x to the fourth, 0x to the third, 0x squared, 0x, plus 5 is our answer. 0 remainder. Okay, so that is our synthetic division. Okay, our remainder theorem says if p of x is divided by x minus k, okay, so if we divide by this like x minus 2 or whatever, then the remainder is equal to p of whatever that is. Okay, so we'll give you an example here. So if I take these and divide these two, let's say it has a remainder of 80. So if we did this, the remainder would be 80 there. Then I know that p of, since this is minus 3, p of 3, if I would plug a 3 into the equation, it would equal 80. Okay, and let's kind of double test that there. If I plug that in here, 3 times 3 to the third minus 2 times 3 plus 5 gives you 80. Okay, and when you divide by this, you get the remainder that's 80. Kind of a neat little thing there. Okay, so if I think about this, if I take this function and divide it by x plus 2, I'm going to get a remainder of 0. So what does that mean? It means that p of negative 2, if I take a negative 2 and plug it in here, I'm going to get 0. Okay, so that's kind of a neat little remainder theorem there. Okay, so if I do this, use the remainder theorem and synthetic division to find p of negative 2. So if it's p of negative 2, I want to divide this by x plus 2, right? Okay, so if I divide that, let's divide it out using synthetic division. So it's negative 1x to the fourth, 0x to the third, 3x minus 3x squared, 4x, and minus 5. So using that synthetic division, bring the first one down, multiply and add, multiply and add, multiply and add, and multiply and add. Okay, so this tells us that p of negative 2, if I plug negative 2 into my function right here, I would get an answer of my remainder, negative 1. Okay, so is 2 a 0 of this function? Okay, so if it's a 0, if you think about it, if 2 is a 0, one way is you could graph this and see does it cross through at 2, right? Okay, but another way to think about that, this would be the point 2, 0, right? So I want to know if I plug a 2 in here, does it equal 0? So one way to find that is to do the long division using the remainder theorem. 1x to the third minus 4x squared, 9x minus 10. Let's see if the remainder is equal to 0 here. Okay, so multiply and add, multiply and add, and multiply and add. So I know that p of 2 is equal to 0. So yes, 2 is a solution, is 0. Okay? So if that's a solution, it has to go through at 2, 0 there. Okay, so next one is negative 2, a 0 of this. Well, let's see if it equals 0, right? So we have 3 halves, negative 1, 3 halves, and 0, right? Plus 0. So bring this down. Multiply gives me negative 3, and add. Multiply and add. And multiply and add. So my remainder is negative 19, right? So that says that p of negative 2 is equal to negative 19. So does it go through at, intercept at negative 2, 0? No. Nope, negative 2 is not a 0, not a solution to that function. Okay, last one here, try it yourself. Is 4 a 0? Okay, bring that down, multiply, add, multiply, add, multiply, add. Okay, so this tells us that p of 4 is equal to 2. Okay, so it goes through that point right there, right? That's a point on the line, but that's not a 0, right? It doesn't go through there. So not a 0, not a solution for us. Okay, next thing is the factor theorem. Okay, says that x minus k is a factor only if p of k is equal to 0. Okay, so remember factoring, right? Okay, so if we want to know if it's a factor of it, we can use the division here. So if it is, okay, we want to know, is x minus 2 a factor? So does x plus 2 times something else equal our p of x here? Okay, that's what we want to know. Okay, so we can do that by dividing this out. Okay, 4x to the third, 24x squared, 48x plus 32. So bring that down and multiply and add, multiply and add, multiply and add. Okay, so is it equal to 0? Yes. Okay, so this is telling us, this is pretty important here, we know that x plus 2 times 4x, x to the third divided by an x is x squared, plus 16x plus 16. Okay, I'll make that a little nicer. Okay, so we know that these are factors. So if we multiply these two together, it will equal our p of x, what we started with. Okay, so if I get a remainder of 0, I know that that is a factor of it. Okay, the next one is x minus 1 a factor. So does this equal x minus 1 times something else? Okay, that's what we want to find out. So we'll take the 1, divide it out, 2x to the fourth, 0x to the third, don't forget that, and 3, negative 5, and 7. So 1 times 2 is 2, multiply and add, multiply and add, multiply and add, and multiply and add. Okay, so is this a factor? Nope, not. It doesn't work evenly, right? So x minus 1 is not a factor. There's nothing that will multiply times x minus 1 to give you this. Okay. Okay, so our third page of notes here for 3.6. We're going to keep going here. Is x minus 2 a 0 of this? Okay, so we're going to find that out first. And if they are, what are the factors and what are the solutions? So we're going to actually solve it out here. Okay, so first of all, is negative 2 a 0? Let's divide it out and see. So 2x to the third, 5x squared, negative 1, and negative 6. Multiply, add, and multiply. Okay, so it is. So we know our factors are going to be x plus 2, and then 2x squared, because x to the third divided by it, right? This is x plus 2 as a factor, right? Because if I set that equal to 0, I get negative 2. Okay, so I get 2x squared plus 1x minus 3, and then 0 remainder. Okay, so those are my factors. So I know what my factors are now. Now the solutions. Okay, so I set x plus 2 equal to 0. I knew that x equals negative 2, right? I had that earlier. How would you solve this? Okay, well, we can try factoring it. Let's see if it factors. If it doesn't factor, we'd have to use the quadratic formula, completing the square. But this will work. If I put a plus 3 and a minus 1 there, that'll be 3x minus 2x is 1x. And if I set them equal to 0, I get x equals negative 3 over 2, and x equals 1. So I just found all the solutions. Now to double check yourself, you could go on Desmos. I know it should go through at negative 2, at negative 1.5, and at 1. Okay? And I know it's positive x to the third, so our graph should look something like this. Okay? Number 18, okay, is 4 is 0. And then if it is a factor, what are the factors and what are the solutions? Okay, so we'll divide it out, see if it works. 1x to the third, negative 2x squared, negative 11x plus 12. Bring down the 4, bring down the 1, multiply gives you 4, and add gives you 2, multiply and add, and multiply and add. Okay, so once again, yes it is. It's a fact, okay? So I know that this factor, right, gives me this solution, which is a factor here. So I know my factors are x minus 4 times 1x squared plus 2x minus 3. Okay, so those are my factors. Let's see if I can factor it even farther. 3 terms, x times x. Yes, it will. So plus 3 and minus 1. And then to solve, I get x equals 4, x equals negative 3, x equals 1. And you could double check on Desmos. X equals 1, negative 3, and 4. The graph should go through at those places right there. Okay, try number 19 by yourselves. Okay, first divide it out. Okay, so once again, yes, it is a factor. So my factors would be x plus 2 and 3x squared minus 1x minus 1. Okay, so I got my factors there. Now I can try and factor this. This one's not going to factor. So I do know that x is going to equal negative 2. That's one of my answers. Now to find this other one, we're going to have to either use completing the square or the quadratic formula, which is a whole lot of fun, right? So I'm going to use the quadratic formula. So I have negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. So that'll be 1 plus or minus the square root of 13 over 6. 13 won't simplify, so I found my other two answers. Okay, so we have 1, 2, 3, because the plus and the minus gives us our 3 answers there. Okay, and you could put that in a decimal form if you wanted to, and check it on Desmos. Okay, now this one's going to be a little bit longer. So we want to know if these two answers, because we have an x to the fourth, right? So let's see if there's these two answers here that will work. Okay, so let's divide this one out first. We'll do 1x to the fourth, 0x to the third, negative 41x squared, 0x's, and then plus 180. Okay, so bring the 1 down, 6, and add and multiply. 36 would be negative 5, and multiply gives you 30, well, negative 30. and then that'd be 180, negative 180. Okay, so they cancel, no remainder. Okay, so I have this. Now, I also want to divide negative 6 out of this. So let's divide negative 6 out of this answer. So it would be negative 6, and that'd be 0, and that would be 30, which also no remainder. Okay, so I have my factors. I know that x minus 6 is a factor, x plus 6 is a factor because both of those divide out. And then what I'm left with, okay, so if I had x to the fourth and I took one x out, it'd be x to the third. Took another x out, that'd be x squared. So I have 1x squared, 0 x's, minus 5. So there I have my factors. Okay, now to solve, I know that x is equal to 6, x is equal to negative 6. Okay, and if I set this equal to 0, I add the 5 over, and I take the square root. Don't forget the plus or minus. So I should have 4 answers, 1, 2, 3, and 4. Okay. Okay, last 4 problems here. What we want to do here is the division of any polynomial. Okay, now this synthetic division is nice, but that only works when I have like just x, like x plus 2 there. Okay, so this is a 2x. Now I could divide it all by 2 and do it that way, but that gets messy with fractions. So we're just going to do long division. Okay, so long division just like we learned in the beginning here. Okay, so what times 2x is 6x squared? Is 3x. And then we multiply that together there. That gives me 6x squared plus 9x. And remember we do this. So that cancels out and we get negative 4x. Bring down the next term. Okay, once again we do the same thing again. What times 2x is negative 4x? So negative 2. So negative 2 times 2x plus 3 gives me negative 4x minus 6. And I'm going to subtract. Those cancel, and that gives me negative 4. Nothing times 2x will give me negative 4, so that's my remainder. So I have minus 4 over my 2x plus 3. Okay, so there's my solution there. Okay, let's try another one. So we have x squared plus 1, 5x to the third, 4x squared, 7x minus 2. Okay, so what times x squared is 5x to the third? 5x. Okay, multiply it through, gives me 5x to the third plus 5x. And I want to subtract, cancels, and that'd be negative 9x squared. I forgot the squared right there. Because that times, nope. There we go. That times that is 5x. I don't want to put it there, right? Oh, I almost messed up. I want to put it there. So then when I subtract, it's there. Okay, so now I have it like terms, right? Okay, so when I bring down, it'd be negative 4x squared. And then I have plus 2x and minus 2. Okay, so make sure you line them up nicely here. Okay, next term. What times x squared is negative 4x squared? Okay, it's negative 4. So if I take negative 4 times this x squared plus 1, gives me negative 4x squared minus 4. I don't want to put it here, right? So I want to put it there with the like terms. And I'm going to do this. So these cancel out, and I'm left with 2x plus 2. Now, will anything times x squared equal 2x? Nope. So that's going to be my remainder. So I have 2x plus 2 divided by my x squared plus 1 as my solution right there. Okay. 2 more problems here. 2x squared plus x minus 1 divided into 1x to the third, 5 halves x squared, 1x, and plus 2. Okay, so what times 2x squared is x to the third? Okay, if I multiply by 1/2 x, so if I take half an x and multiply it by 2x squared plus x minus 1, half of 2 is 1, right? So it would be 1x to the third. That would be 1/2 x squared. And this would be minus 1/2 x. Okay, once again, we're going to draw the line and change our signs here to subtract. So those cancel. 5/2 x minus 1/2 x is 4/2, which would be 2x squared. 1/2 plus 1 would be 1.5, so 3/2 x. And we're bringing the 2 down. Once again, what times 2x squared is 2x squared? 1. So 1 times this gives me 2x squared plus x minus 1. I want to subtract. So those cancel. 3/2 minus 1 would be 1/2 x. And 2 and be 3. And that's our remainder, right? Because nothing times x squared is going to give me an x. So I have plus 1/2 x plus 3 divided by my 2x squared plus x minus 1. Okay, last one. Okay, so what times x squared gives you 3x to the fourth? 3x squared. And I multiply, that gives me 3x to the fourth plus 3x to the third minus 3x squared. Okay, I'm going to subtract now. So those cancel. That gives me negative 1x to the third. And that gives me plus 2x squared. And I can bring down those next terms if I want. Okay, same process over. What times x squared is negative x to the third? A negative x. Okay, it gives me negative x to the third minus x squared plus 1x. Okay, draw the line, change the signs. Cancels. 3x squared plus 3x minus 3. Okay, what times x squared will be 3x squared? 3. Gives me 3x squared plus 3x minus 3. And notice when I subtract all those, it gives me 0 remainder. So we know there's our solution. This times this will equal this. Okay, those are the long 3.6 notes.